but I just need to figure out what are my concentrations. Like, what is my concentration here? Now, that's basically what I want to know. Okay? So, if I put 25 milliliters, 0.001 molar of lead, I need to figure out how many moles is that, and then divide that by the total volume. Okay? And I want to do the same for sulfur. And then I'm going to set it equal to my KSP expression, right? And just see if my Q is bigger than my K. You guys remember that? Q bigger than K kind of stuff? Let me grab my sheet. We'll do it really quickly. Okay, so how I do this is I start off and I say, okay, I have 25 milliliters. 25 milliliters, well, I know that for every 1,000 milliliters, I have 1 liter. According to my concentration for every 1 liter, I have 0.001 moles of Pb2+. How many moles is that? Well, let's do it really quick. I have 25 divided by 1,000 times 0.001. Okay, so I have 2.5 times 10 to the negative 5 moles, and I want to put that in concentration. So the concentration of my total volume now, if I add this much to this much, is now 35 milliliters. So I'm going to divide this by 0.035 to get the concentration. And I do that, and I figure out that the molarity of Pb2+ is equal to 7.14 times 10 to the negative 4. Awesome. I'm going to keep that in mind. Okay? Now I just got to do the same thing for the other item. So I start off with 10 milliliters. I know, again, for every 1,000 milliliters, I have 1 liter. Right? The concentration tells me that for every 1 liter, I have 0.1 moles of S2 minus, right? And so I want to figure out how many moles is that. So I do it, 10 divided by 1,000 times 0.1. I have 0.001 moles, but I now need to find out what is the molarity of that. So it's the same total volume. I divide by 0.035. And I get a total molarity, so the molarity of S2 minus is equal to 0.02857. Okay? So I have the two molarities. I know what is the concentration of both ions in there. All I do now is plug those numbers directly in for the KSP expression. The KSP expression for this specific salt, right, looks like this. It's getting a little messy, but try to make it clear as you can. 3 times 10 to the negative 28 is equal to x of the one times x of the other, right? In lead, 2 sulfide, it literally just looks like this, right? So I don't have 2 of any. There's no squares here. There's no 2 x's. So all I got to do is plug these numbers in directly there, right? And what I'm looking for is not my KSP because I have that. I want to solve for Q, right? So when I plug these in, I'm not setting it equal to that. I'm just putting it into the expression and solving for, okay, what is Q then? If that's what KSP is, what is Q? And I do the same thing we did for equilibrium. When I say that I put Q and K, right? Q and K and Q and K, right? I do 3 times, and I have to compare them. And in this case, when I do the math, anybody do it? Yeah, what did you get?
2 to the negative 5.
Okay, 2 to the negative 5. Okay, you got 2 times 10 to the negative 5. When I took these two, multiplied by each other, my Q came out to equal this. Is that greater or smaller than my KSP? Greater by a lot. So Q is greater. So the arrow runs this way. Will it precipitate form in the reaction? I go back towards my reactants? Yes. The answer is yes to this. If Q had been less than, would it have precipitated form? No. If it had been equal to, we're at equilibrium. So I would say no as well. But this is the important one. Q is greater than. Okay? So that's how we did that. We found out the overall molarity. We plugged it into the KSP expression, right? And we solved for Q, and then we compared the K and Q. That is all for KSP. We have this one last problem. You guys want to stick around for the last problem? You guys are okay with that? The last problem is quick as well. Last question on that. Was that okay? We kind of raced through it, but practice a problem like that.
You walk
decide
too
specific
fast.
form. Oh, did it? I'm following. Okay. Okay. So what we're gonna do here is we're gonna do this problem. I need you guys to solve this problem. This is review on equilibrium, and I'm gonna give you the last two values you need to know. 0.001 and 1.15 times 10 to the -3. We have two equations. I have the k for both equations. This is the overall equation. I want to know what is the overall k of this reaction. There's going to be some manipulations going on, and you have to remember how I manipulate my k compared to what I do to the equation. Then there are answer choices, and we're going to have you do the same type of voting system. We're going to have you do that. Do the last time.
Give him like 2 minutes.
What?
Just give him like 2 minutes.
Yeah, you guys have 2 minutes. Just get as far as you can, I guess, and maybe we'll switch it up. Okay? Huh? You're safe. Oh, you're good.
Right there, right there. Okay. All right, you guys. Let's go through it. Let's solve this really quickly, okay? So, number one, I see my overall equation. I see the two that are somehow coming together. The equations themselves are adding together to give you this. So there's some manipulation I have to do. What's the first thing that some of you notice? I like to go off the most obvious one. I see this, and I see that, well, I have a plus b plus f. That's probably the one I noticed first. Over here I have a plus b, c plus b. I need f as a reactant, so I flip this equation, right? Okay. Big question. If I flip this equation, what do I do to my k? Inverse. Take the inverse. Exactly. I'm going to go 1 divided by that. So now my k is equal to this. This is flipped. Okay? So we'll flip it. Is that what it was before? C. D. There it is. Sorry, I erased a little bit. Okay, so now what about this? What do we got to do? How are we going to do that? I need to divide by 2. Exactly. Divide the whole thing by 2. Which is the same as multiplying by half. So I'm multiplying everything by a half here. Everything. So what that does is it gets rid of this number, this number, this number, and this number, but it leaves me with 2 here. Right? Are my equations ready to be added together? How do I manipulate the k of the top equation if I divide it by 2 or multiply by half? What do I do? Square root. And I like to raise it to the 1/2. I like to keep the rule, a one-step rule. Whatever I multiply by, I raise it to. So if I'm dividing by 2, I know I'm multiplying by a half, so I raise it to a half. Just keep it just all about raising it to a certain power. Okay? So this is raised to the 1/2. Okay? So these add up, I get this, that's great. Who did the math?
27.5.
So A. A is the correct answer. I get 27.5 for my overall. Now, these answers are all bogus, but they come straight from these numbers. If you would have forgot to take the inverse, but just did a negative, then you would have got one of these negative numbers, which means that if you ever get a negative k, that can't exist. So don't do a negative k, ever. Okay? These will be if you did the negative this. Where does that come from? Changing the sign. It comes from Hess's law of thermodynamics. This is totally different. And a lot of times we confuse the two. Okay?
At the end, we multiply the numbers, right?
At the end, we multiply the two k's together. We do not add them. Adding them is what? Hess's law as well. So these two laws can sometimes get confusing. We multiply the k's together, right? So if you forgot to raise to the half, you would have got one of these. If you change the sign, you would have noticed that the rest of these answers would come from this little mistake. This is the correct answer. So